Hi everybody, here's number 15 from the chapter 3 review that I promised to do for you guys. So we have a cone and inside we have a right cylinder inscribed. A really difficult part to this problem I found is labeling. So here I will label the cone's dimensions in black. That's going to be the height of the cone, and R is going to be the radius of a cone. Okay, so for our cone, we have a radius, we have a height, and then we have our formula for the volume. Right? Then we also have a cylinder in here. Now let's go ahead and give the cylinder's dimensions in blue. Now this is kind of tricky. We don't want to call the radius to the cylinder R. So for the heck of it, I'm going to call it X. Okay? We don't want to call the height of the cylinder H. So just for any variable, I am going to pick Y. Is that okay? So for my cylinder, X is going to be the radius, Y is going to be the height of the cylinder, and if we recall our formula for a cylinder's volume, we have the area of the base times the height. Now we are looking for the largest possible volume of our cylinder. This next part I feel is rather tricky because what we're going to need to do, we are going to have to consider this cross section right here. Okay, I'm going to redraw it here for you. And inside of it, so this is my radius, and this whole part here is still my height, right? And then if you notice, we have an X value right here. And we called the height of just the cylinder Y. So that red triangle is just across a triangle like cut out of that cone. So go ahead and compare the variables. What we're going to do here is we are going to use similar triangles because these are both right triangles. Now another tricky part here is, well, what is the height of this small triangle on top? Well, it would be H subtract Y, right? So I think that part is a little tricky to set up as well. Okay, from here we are going to use our similar triangles. So we're going to go radius is to radius as the height is to the height. Here we're going to go ahead and we're going to cross multiply and we're going to isolate a variable. So I cross multiplied, I distributed, brought over the RH to the left side, divided both sides by negative R because I'm trying to isolate my Y. And so using similar triangles, I solved for just my Y variable here. Now take a moment and please revisit the blue formula for the volume of a cylinder. Please notice that I used pi r squared h, but in this problem we're letting our radius be x, right? And our height be y. So I went ahead and I substituted those variables, and from here I am going to actually substitute my y value, the y value that I got in red down below. Okay? Take a moment and look at that. Oh, and forgive me, I just noticed a slight little error in my red formula. I forgot to write my negative r in the denominator, so I'm going to go ahead and do that, or my r. I should have written my r here, forgive me. Let's see if I can get this right. Okay, there we go. So let me fix that in blue as well. I have to have my r in the denominator here, right, when I plug in. So all I did was substitute this value into this y value right here. Moving forward, we're going to distribute. And I'm going to go ahead and just simplify this just a little bit more. Okay, now we're looking for our maximum volume of the cylinder, so I am going to take the derivative of this with respect to x. Remember, r is just a constant, h is just a constant, so we don't touch those, right? They're just constants in this problem. And I'll just rewrite that a little better here. Maybe you're beginning to see why I didn't want to spend too much class time on this. Okay. All right, so we have our derivative here. We have to find our critical points by setting it equal to 0. So if you need to, go ahead and pause the video to see how I factored that. But basically, we're going to use our zero product property here. And we will get that x is either going to be equal to 0 or x is going to be 2r over 3. Now we know we don't want the radius of our cylinder to be 0, so we're going to go ahead and disregard that one. And just keep in mind for a second, if the radius was 0, that means the cylinder would have a volume of 0, right? So that could be considered a minimum, but there really is no volume, so I'm just disregarding it. So we definitely have a critical point at 2 pi over 3. Now once again, I'm going to keep this in blue because we're still doing the volume of the cylinder, but let's go back to our formula that we wrote above for the volume of a cylinder. It was this, right? Now check this out. Do you see how x is 2r over 3? See where we're going with this? Very tricky, isn't it? We are going to plug 2r over 3 in for x. Simplify that. Now you're going to notice we also have this y value here, and if you look up here, we had an expression for y. Well, you know what? We just solved for x, didn't we? So we can plug this x value into y now, and I'll do that again in red since we're working with y. First, if you don't mind, I'm just going to factor out the h, okay? And now I'm going to substitute the x value over here. Oh boy. Okay, so if we simplify what's in our parentheses over here, we'd get y to equal h times 1 minus 2r over 3 over r. I know you can't read that, but in black, those r's are going to cancel. So we're left with 1 minus 2/3 inside the parentheses. Go ahead and pause the video if you're having trouble seeing that. So in other words, we're left with y equals h times 1 minus 2/3, which is the same as 1/3 times h, because 1 minus 2/3 is 1/3. So keep this in mind. 1/3 h equals y. Oh boy. Here we go. I'm going to erase some of the diagrams at the very top so we have a little room to finish this. Okay, and I'll go ahead and finish this in green. Please remember, so here is our formula that we have so far, and we have just solved for y. So I'm bringing these up to the very top in green, like so, but instead of writing y, I'm going to write in what y equals. Yes? And then from here, we'll multiply this. 4 times 1 is 4. 9 times 3 is 27. All right, and there you have it. And there is our answer. Thanks, guys. I hope that was helpful to you. So now I see